Okay, let's dive in. We're looking at something pretty fascinating today. The idea of solar panels that work even when it's, well, raining.
Yeah, rain-powered solar panels. It sounds a bit counterintuitive, doesn't
It
it?
really does. So we're basing this discussion on a white paper from Black Knight Power.
Hmm.
They're exploring this hybrid tech.
Exactly. It combines standard solar cells, the photovoltaic or PV ones we know, with something called triboelectric nanogenerators. TINGs for short.
TINGs.
Eh?
Right. And the idea is to get energy from sunlight and from raindrops hitting the panel.
That's the goal. Capture energy from both.
So our mission here is to unpack this, see where the tech actually is today, and figure out why it might matter, especially somewhere like Illinois.
Illinois is a great example, actually. They've had this huge surge in solar installations.
Yeah, something like 44 times more since 2013, I read. Huge growth.
Huge. But Illinois also gets its share of cloudy days, rain, snow. Even pollen can be an issue for panels. So this idea of an all-weather panel is really relevant there.
It addresses that variability problem, potentially.
Yeah.
Making renewables more consistent.
Precisely. And those TNs you mentioned, basically they generate a tiny bit of electricity from the mechanical energy of a raindrop landing on the surface.
Okay, but how does that work? How does a little drop of rain actually generate power?
Well, think of it like static electricity almost. The panel surface has special layers. When a raindrop hits and then moves or bounces off, there's friction and contact between the water and those layers. They're designed so that this contact and separation actually causes a tiny exchange of electrical charges.
So it's not just the impact force, it's the interaction,
Yeah.
the touching and separating.
Exactly right. That interaction creates a momentary charge difference, a tiny voltage. And if you have electrodes built in, that voltage can push electrons around, a small current.
Okay, harvesting energy from the rain itself. It makes conceptual sense. But based on the source, where are we actually at with this technology? It sounds promising, maybe helps with grid stability down the line, but it feels very early.
Oh, it's definitely early days. And there are some pretty big hurdles. The main one the paper discusses is energy density. It's just really low right now.
How low are we talking?
We're talking maybe 0.35 watts per square meter from the rain component.
0.35. Okay.
Yeah.
Compare that to standard solar for me.
Right. A typical solar panel gets you, what, 150, maybe 200 watts per square meter from sunlight. So it's a huge difference. Orders of magnitude less power from rain right now.
Wow. Okay, so you need an absolute massive area just to get a trickle of power from the rain part.
That's the fundamental challenge, yeah. Physics is tough sometimes.
And what about just holding up to the weather? Solar panels need to last decades.
That's the other big thing, durability. The source mentions some prototype materials start degrading after only about 10,000 rain cycles.
10,000.
Yeah.
That sounds like nothing compared to 25 years outdoors.
Exactly. Traditional panels face millions of weather cycles. So, yeah, the Tang part isn't nearly robust enough yet for long-term use.
And I bet adding this tech isn't cheap either.
You got it. The prototypes, they're looking at maybe 2 to 3 times the cost of a standard PV panel. That should come down with scale, hopefully, but that's where it is now.
Okay, so let's bring it back to Illinois. You've got the weather challenges, making this tech appealing in theory, but then you've got these current limitations, low power, durability, cost. What's the practical advice today?
Well, looking at the numbers in the Black Knight Power paper, even factoring in things like the 30% federal tax credit and Illinois' own SREC program.
Which help a lot with upfront costs.
They do, but the estimated payback for these hybrid systems is still projected at like 9 to 12 years, and that's assuming they actually get a decent boost from the rain harvesting, maybe 15%, which is still a bit theoretical, compared to traditional solar in Illinois right now, where the payback is often closer to 7 years.
So for our listeners in Illinois thinking about going solar now,
The sensible advice, based on where things stand, is probably to go with traditional solar. And maybe do it sooner rather than later, especially before that one-to-one net metering policy in Illinois potentially changes after 2025.
right, that net metering is key to the current economics.
It really is. And when you install, maybe think about those practical add-ons for the local climate things like tilt mounts to help with snow, or those pollen-resistant coatings the source mentioned.
Okay, standard solar now, maybe optimize it for the conditions, but keep an eye on this Tang stuff for the future.
Absolutely. It's not ready for your roof today, but the estimate is maybe commercial viability in, say, 3 to 5 years, perhaps pilot projects around 2028.
And there's ongoing research, right? I saw mentions of polymer-based tanks, maybe even using biodegradable materials.
Yeah, work happening at places like the University of Illinois, leveraging the state's agricultural strength for materials science is an interesting angle. And other related tech, like thermal electric hybrids being looked at near Naval Station Great Lakes, could also feed into better all-weather designs eventually.
It feels like Illinois, with its climate, its solar market, its research base, it could actually be a good place to see this develop further.
I think so too. The ingredients are there.
So, okay, we're not powering cities with thunderstorms just yet. But this whole area of rain-powered solar is a really interesting glimpse into tackling the intermittency of renewables. It makes you wonder, doesn't it? What would a truly all-weather energy source really mean for us, especially in places where sunshine isn't always guaranteed?